Hello everybody. So here is a video for you to go through the things that we need to know for Monday. So on Friday we talked about the concept of constant rate of change. And constant rate of change we said was change in y over change in x. Well, we can also realize and understand that it is also called slope. Constant rate of change and slope are the same thing. And if you remember on Friday, we said delta y over delta x. Okay? So constant rate of change and slope are the same thing. We can look at slope and constant rate of change on graphs and interpret the slope and the y-intercept of 0, 0. Y-intercept is when the line of a graph intersects the y-axis. So if we're going through 0, 0, that is the origin. Use similar triangles to develop an understanding of slope. All right, so here we have Misty Flip. She worked odd jobs all summer long and saved her money to buy passes to the ski lift at the High Ratio Mountain Ski Resort in August. Misty researched lift tickets prices and found several options. Since she worked so hard to earn this money, Misty carefully investigated each of her options. All right, so here we have High Ratio Mountain, and it tells us that the daily lift ticket is $30. A 10-day package is $80 right at the purchase, plus $20 per day. And we also have the option of the unlimited season pass. So here we have, suppose Misty purchases a daily lift ticket each time she goes skiing. So if we do a daily lift ticket, we are paying $30 per day, right? So if we don't go at all on days of 0, our cost would be 0 because we haven't done anything. If we go one day, we pay 1 day of a lift ticket, so that's $30. And 2 days of a lift ticket would be 2 times 30, and we get 60, and so on and so forth. So we could fill out this table following that general rule, just like we did with constant rate of change. As you will see, the constant here is adding 30. The constant here is adding 1. Okay, so your constant rate of change, remember, maybe things to know is the top row would be your x value, your bottom row would be the y value. So if you're talking about delta y over delta x, we are talking about the delta y as a positive 30, and the delta x, which is the top, would be positive 1, and our slope is 30. Okay, so that's what you're doing on the first page here. Looking on the second page here, it says let D represent the number of days for which Misty bought lift tickets, and C to represent Misty's total cost. Write an equation that can be used to determine the total cost of lift tickets if Misty skis for D number of days. Well, if we think about going back to the original problem here, if we said 6 days, I'm sorry, let me use one that we actually did here. If we said 2 days, we did 2 times 30. Okay, because if we're going to pay for 2 tickets, we're going to pay $30 twice, and we get 60. Well, in the question for number 3, for D number of days, our cost will equal the number of days times 30. Okay, and that would be 30D. And if we can graph this, then we can plot data from the table, and we can plot this graph just like we did in school on Friday. So here we would start at 0, 0. At 1, we would be at 30. And at 2, we would be at 60. And you have to estimate these values just like we did in class, and keep working that through. When you do graph this, you should get a line, a straight line. So here be the fact that they are giving you a graph, we can draw a line to kind of show that. Let's see how I did here. If we did 8 days times 30, that should be 240. So I'm a little bit off here, but that's all right. So you can see that there we go. You can see that if you were to plot all of your values from the table, you will plot those points first and then draw your line through your dots. Over here, we number 5 says label the leftmost point on the graph as point A. Label the next 6 points from left to right. Okay, so if we're going to do that, we would come up here and I would have A and then B and then C and keep going to label your points. Number 6, let's reason quantitatively. According to the graph, what happens to the total cost of the lift tickets as the number of days increases? Okay, you could justify that, I think, on your own. Number 7, describe the movement on the graph from one point to another. What is my vertical change? So my vertical change from point A to point B was what? $30, right? So that vertical change was $30. And what was my horizontal change? 1 ticket, right? So 1. And how about from B to C? From B to C, okay, I went from $30 to $60, right? So think about what we did on the table. That's a change of a positive 30. And my horizontal, if I go from here to there, that is 1. Now, generally speaking, we would normally do this as if we're doing our vertical change and our horizontal change, we would do vertical change goes up like that, horizontal change goes over like that. So we could label it 30 over 1. And then we could go from B to C, up from 30 to 60, that's 30, and over 1 more ticket, 1 more day. Okay, so we're kind of showing that constant rate of change, kind of like what we did on the table. On the table, we had 0, 0, 1, 30, and 2, and 60. We went, okay, well, going from 0 to 30, that's positive 30. Going from 0 to 1, that's positive 1. Going from 30 to 60, well, that's still an increase of 30. And going from 1 to 2, that is still an increase of 30. So you should be able to fill out the rest of this table with the same understanding. Moving on to page 135. The movements you traced in item 7 can be written as ratios. Write the ratios in the form of vertical change over horizontal change. So obviously the vertical change was an increase of 30. The horizontal was a change of 1. So then B to C, C to D, and D to E. All right, all good to go. Pretty much the same, right? Part B here says vertical change can also be described as change in Y over change in X. And so here we see vertical change, horizontal change is change in Y over change in X. Write the ratios as change in Y and change in X. Well, that's the same thing. Change in Y over change in X. Continue to use the data from item 4. All right, well, going from B to E. All right, well, let's think about B to E. If we go back to our table and we, on the very first thing here, if we said this is A, this is B, this is C, this is D, E, F, and G. If we label those, then we can identify point B would be 1 in 30. Point E would be 4, and 4 times 30 is 120, correct? So E would be 4 and 120. So going back to our problem here, yeah. All right, so from B to E, B was 30, well, let's think, 1 in 30, and that was B. And E was 4 and 120, right? So our change in Y goes from 30 to 120. So that's an increase of 90. 1 to 4 is an increase of 3. So that would be 90 over 3. If I look at the graph up here, right here, then 4 and 120, that was right there. So if I go from B, which is right here, this is B and this is E. So if I go from B, I'm going from 30 to 120. So I'm going up 90, and then from here over, that's 1, 2, 3 units. So I can go from 90 over 3. So you could get the same value, the same information of 90 over 3 either from the table or from the graph. And you would get an increase of vertical change. We could also think of this as rise on the graph. When we're thinking about the graph, you're rising up or down over the run going sideways. So rise is up or down, and run is left or right. So that's if you're using the graph. So that's thinking about what we did on the graph. Sorry. So 90 over 3, and if we simplify that, what do we get? 30 over 1, or 30. So finish out these the same way I just did with B to E. Looking here at number 9, describe the similarities and differences in the ratios. Okay, you can do that after answering those problems. Number 10, make sense of the problems. What are the units of ratios created in item 8? Explain how the ratios and units relate to Misty's situation. We can keep going. You can finish that. 11, how do the ratios relate to the equation you wrote in item 3? Okay, you can come up with something for that. Think about the ratios. They might have always come down to 30 over 1, right? And our equation that we wrote was C equals 30 times D. So, our ratios were always came down to 30. Look at that, the $30 per day, right? Number 12, the ratio, change in Y over change in X, between any 2 points on a line is a constant. Use the diagram, okay? So we're looking down here from W up to V. We're going up 3 and over 5. So here, you know, if you're looking at this line, WZ is a line on the graph, and you're looking at, you know, okay, going from point W to point V, I'm going up 3 units and then over 5. Just like I said, rise over run. I'm going up 3 and over 5. So 3 goes up, that's my vertical change, my change in Y, over my change in X, so 5. And then if I look at going to a different point on that line, I go up 6 and over 10. Well, going up 6 over 10, well, those are the same ratio. These are proportional. It's a constant rate of change. So regardless of any points I choose on a line, because of its constant rate of change, those ratios are always going to be equal to each other. It's just a matter of simplifying the ratio to its simplest form to get 3/5 being the same as the smaller triangle here. Okay, moving on. Slope. This is called, they're talking about slope here is change in y over change in x. When you talk about a line on a graph, the angle that you are talking about, that the line on the graph is showing you, that angle is the slope of the line. So the slope is the constant rate of change, just like we talked about at the very beginning. Sometimes it's also called the average rate of change. Okay, here's something that we need to understand. All linear relationships have a constant rate of change. If you have a line that's not a line, or a graph that's not a straight line, well, then that's not a constant rate of change. Next one, the slope of a line is what determines how steep or flat the line is. Okay, if you have a line that goes like this, that's a very steep slope. If you have a line that goes like this, that is a very flat slope. So steep slope, you're going to have a number kind of probably bigger than 1. And for a flatter slope, that's going to be a number smaller than 1. Number 13 says draw a line through the points you graphed in item 4. Use the graph to determine the slope. Okay, you should be able to do that. And then complete the table to show the data points you graphed in item 4. Use the table to indicate the ratio change in y over change in x. Seems like this is the same table you should have from that very first page, just shown in a vertical table instead of horizontal. And then you could figure out your change in y, your change in your x, and you can come up with these things. Really, these are the same. This is the same information, whether you're looking at the original table or you're looking at the points on the graph. All right, last page here. I think you guys can do this on your own, and then be ready to do all this in class on Monday. All right, you guys have a good day on Monday. Be good for the sub. Thank you.